Alright, today we're going to start actually writing proofs for proving triangles congruent. So to start off with, here's just some general guidelines since we're just learning kind of how to do proofs and still trying to get comfortable with that. Okay, using the information given, you want to label your picture. So we want to mark anything congruent that we know is congruent and any other information that might give us. Then the first statement of your proof should always be what was given, and the reason for any given information will always be that it was given. Okay, deduce all possible information from that given until a congruency is reached. If we're trying to prove that triangles are congruent, we need to know some sides and or angles are congruent to each other. So any given information, if it's going to lead us to proving the triangle is congruent, it's going to have to lead to some pair of sides or some pair of angles being congruent. So from that given, find out a congruency, find a pair of angles congruent or a pair of sides congruent, and then we'll just repeat that process with any other given information. Go with the given, find a congruency. Take a given, find a congruency. Alright, if you have used up all of your givens and you do not have three congruencies, because we need three congruencies, side, 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 angle, side, angle, angle, side. Even hypotenuse, leg, we got to know right angles first. So there's always three things that we know are congruent to be able to say the triangles are congruent. So if you still don't have that, then you want to look for a reflexive side, a reflexive angle, or a pair of vertical angles to get a congruency. So they'll either be sharing a side, sharing an angle, or you can recognize some vertical angles in the picture. So look in the picture for something. Once you have three congruencies, determine if the triangles are congruent by side, 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 angle, 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 side, or hypotenuse, leg. Those are your possible ways of proving triangles congruent. And your last statement should be whatever you were supposed to prove. And the reason's going to be one of those postulates or theorems we use to prove triangles congruent. Now later on we'll get into other proofs and you won't necessarily be able to follow this procedure exactly, but this is the procedure we go through for proving that triangles are congruent. So let's look at the first one and let's see how we do. Alright, start with what we know. Line segment AD is congruent to line segment AB. First thing I do, label the picture. I'm going to mark those congruent. Then it tells me line segment DC is congruent to line segment BC. Alright, so I'm going to go ahead and put the given information in here. Line segment AD is congruent to line segment AB. I know that is true because it was given. Now that in itself is already a congruency, so I don't need to follow it out to anything else. I'm ready to move on to the next given. Line segment DC is congruent to line segment BC. Again, because it was given. And again, that is a congruency, so I don't have to follow it out to anything else. Now I've used up all the givens and I only have two pairs of congruencies there. I need another pair of congruent angles or sides. When I look at the picture, I notice that line segment AC is being shared by both of these triangles. It's a side length for both of them. So that's a reflexive thing where I know that line segment AC for one triangle is congruent to line segment AC from the other triangle. And that is called the reflexive property. When something is congruent to itself, when you got the exact same thing on both sides of an equation or a congruent statement, that's using the reflexive property. Now I notice I have three pairs of congruent sides. I am now able to finish this off. I can say what I'm supposed to prove here, that these two triangles are congruent, and the reason they're congruent is by side, side, side. I got three pairs of congruent sides. Those triangles have to be congruent based on side, side, side. Alright, let's try another one. Alright. Line segment AC bisects angle DAB. Well, I know that line segment AC bisecting angle DAB means it splits that angle into two congruent halves. So I'm going to mark those congruent. And then this tells me angle 1 is congruent to angle 2. Alright, so let's start writing our proof here. I'll start with the first given. Line segment AC bisects angle DAB, and I know that's true because it was given. Now that given is not a congruence statement. It's not telling me anything's congruent directly. But when I read that, I knew to mark two things congruent because I know what bisect means. It means it split this into two congruent halves. So because of that, I said angle DAC is congruent to angle BAC. And that was based on what bisect means. So the reason for that is the definition of bisect. Okay, so I got a congruence from that given. Move on to the next given. Angle 1 is congruent to angle 2 because it was given. Now I've used all the givens and I only have two congruencies, so I need to look to the picture for a third one. And similar to the last problem, these two triangles are sharing a side. Line segment AC is a side length for both triangles. So line segment AC is definitely congruent to itself. That's your congruent sides there, and that's using the reflexive property. So at this point I have three congruencies, and I do have enough to prove these triangles are congruent. So I'm going to go ahead and finish the proof. Triangle ABC is congruent to triangle ADC by angle, side, angle. I got two pairs of congruent angles, one pair of congruent sides, two A's and an S, and that S, that side, is the included side. It's between the A's. Angle, side, angle proves that those triangles are congruent. Okay, let's try one more before we move on to something else. Alright, C is the midpoint of line segment BD. Alright, well if C is the midpoint of line segment BD, I know that it splits that segment into two congruent halves. The midpoint always bisects a segment. And then C is the midpoint of line segment AE, so it's also going to bisect this segment. Alright, so that's all the given information. So let's start writing the proof. C is the midpoint of line segment BD, and I know that's true because it was given. Now because C was the midpoint of line segment BD, I marked a couple things congruent. So because C was the midpoint of line segment BD, I can say line segment BC is congruent to line segment CD. And that was based on the definition of midpoint. Because I know what midpoint means, I knew that it was going to split that into two congruent segments. So I know those are congruent because that's what midpoint told me. Alright, I'll go with the next given. C is the midpoint of line segment AE because it was given. And as soon as I read that piece of given information, because C is the midpoint of line segment AE, I knew AC and CE were going to be congruent. Those two segments are congruent, and it's for the same reason I knew the other pair was congruent. It was based on the definition of midpoint. Now I've got two congruences, but I need three, and I don't have any more given information, so I got to get it from the picture. And if I look at the picture, I see a pair of vertical angles. I know that vertical angles are always congruent, so I can say that angle BCA is congruent to angle ECD because they're vertical angles. So that is the vertical angles theorem. The vertical angles theorem tells us that vertical angles are congruent to each other. And now I got three congruencies, and it's the good three congruencies where I can actually say the triangles are congruent. So I'm going to say triangle ABC is congruent to triangle EDC. I got two pairs of congruent sides, one pair of congruent angles, so that should be two S's and one A. And notice the angle is between the sides. It's the included angle. So the A is between the S's. I can prove these triangles are congruent by side, angle, side. Alright, we're going to add one other thing to what we're doing right now. We're going to talk about CPCTC. And we actually introduced this back in the first section of the chapter. CPCTC means corresponding parts of congruent triangles are congruent. Remember, congruent triangles, all their corresponding angles are congruent, all the corresponding sides are congruent. So if we can show that triangles are congruent, then we'll know that their corresponding parts have to be congruent. So for example, right here, triangle CAT is congruent to triangle DOG. So knowing that they're congruent, all their corresponding parts are congruent. That means angle C and angle D are congruent. Angle A and angle O are congruent. And I'm doing this based off the congruent statement because remember the congruent statement goes in corresponding order. And then angle T, last letter, is congruent to angle G, last letter. So all those angles are congruent. I can do the same thing with the sides. Looking at that the congruent statement, first two letters CA, first two letters DO. Line segment CA is congruent to line segment DO. Okay, same thing with the last two letters. Line segment AT is congruent to line segment OG. And then finally, we can create a segment with the first letter and last letter also. So line segment CT and line segment DG. Line segment CT is congruent to line segment DG. And I'm going to go ahead and label the picture up with these things. Angle C congruent to angle D. Angle A congruent to angle O. Angle T congruent to angle G. Line segment CA congruent to line segment DO. Line segment AT congruent to line segment OG. And finally, line segment CT congruent to line segment DG. So just by knowing that those two triangles were congruent, I knew all of these parts were congruent because corresponding parts of congruent triangles are congruent, CPCTC. So how many congruencies does it take for us to show that two triangles are congruent? If you think about all the postulates and theorems we use to show that triangles are congruent, it was always 3. Side, side, side. Side, angle, side. Angle, side, angle. Angle, angle, side. And even hypotenuse, leg, you got to know you got the two right angles, which should also be congruent. So you got right angles, then the hypotenuses, and the legs. So we always need 3 congruencies to show that triangles are congruent. So then how many additional congruencies could we deduce? So if I have 3 pairs of congruent sides and I say the triangles are congruent, there's still some other things that we hadn't known were congruent previously that we now know are congruent. Because in 2 congruent triangles, there are 6 congruencies. So if we only use 3 to show that a triangle is congruent, there are 3 more that have to be true once we know the triangles are congruent. So we're going to use that in some proofs. So what this is going to do, we're basically going to do the exact same thing we've been doing. We're just going to take it one step further. So we're going to approach this just like we've been doing. We're going to prove these triangles are congruent first, and then I'll show you how that allows us to prove that angle S is congruent to angle T. So we start out with line segment RZ bisects angle TRS. So I know because it bisects it, it's going to split it into 2 congruent parts. And then angle 3 is congruent to angle 4. Angle 3 congruent to angle 4. So writing the proof, line segment RZ bisects angle TRS because it was given. Because I know it bisects angle TRS, I knew that angle 1 and angle 2 were going to be congruent. Because I know what bisect means. So that was based on the definition of bisects. Okay, the next given was that angle 3 was congruent to angle 4. So after I've used up all the givens, I only have 2 congruencies. I need 3 to show that the triangles are congruent to each other. So I look at the picture, and I notice they're sharing this side. So line segment RZ is congruent to itself. It's a side length for both triangles, and it's the same length for both of them. And that's based on the reflexive property. Okay, at that point, I have 3 congruencies. I just figured out I got a pair of congruent sides right here. So now I know that these triangles are congruent. So when I write a congruent statement, it's got to go in corresponding order. Now I can name the first triangle in any order I want. So I'm going to call this top triangle RTZ. But when I name the second triangle, I got to be careful to make sure it goes in corresponding order. So RTZ would correspond with RSZ. Make sure it's in corresponding order. And the reason I know those are congruent, angle, side, angle. Angle, side, angle. Got two pairs of congruent angles, and I got the included sides congruent, the side between the angles. So now I know those two triangles are congruent. So now we've been doing those now, earlier in the notes. How can I then take that and say that angle S is congruent to angle T? Well, if I know these triangles are congruent already, then I know all their corresponding parts have to be congruent. Does S correspond with T? Yes, it does. Well, if these triangles are congruent, those corresponding parts have to be congruent. So I know this is true because corresponding parts of congruent triangles are congruent. Alright, I'm going to try one more example. Once again, we want to prove that angle A is congruent to angle B. We're going to start out by proving that triangles are congruent, and then we can use CPCTC to finish things off. So we start off with line segment AB bisects line segment CD. Now be careful here. Some people want to try to mark these congruent. That's not what it's telling us. This is the saw or the knife that's bisecting something. It's cutting something else into two congruent halves. Line segment CD is being bisected. It's the one getting cut into two congruent halves. So based on that statement, I know that these segments are congruent. And then they also told me angle C is congruent to angle D. Alright, so that's all my given. I've marked it in the picture. Let's start writing things into the proof. I know line segment AB bisects line segment CD because it was given. And based on that, I knew that these segments were congruent. So I knew line segment CM is congruent to line segment MD because that's what bisect means, based on the definition of bisects. Alright, so then I went to the next given, and it told me angle C is congruent to angle D. That's true because it was given. Now I only have two congruencies here. I need a third one, so I go to the picture. And I see in the picture, I see a pair of vertical angles. Those angles are congruent because they're vertical angles. So I can say angle AMC is congruent to angle BMD. Because they're vertical angles. So that's the vertical angles theorem. And now I have three congruencies. So if it's the right three congruencies, I can say the triangles are congruent. By angle, side, angle. Angle, side, angle. I can prove these triangles are congruent. So I'm going to say triangle ACM. Remember, I can name that first triangle in any order I want. But then I got to make sure the other triangle is in corresponding order. So the A corresponds with B. The C corresponds with D. And the M's correspond. So those triangles are congruent, again, by angle, side, angle. Angle, side, angle. I got two pairs of congruent angles. One pair of congruent sides. I got two A and an S. And the S is between the angles because in here that is the included side. It's the side between the angles. And now that I know the triangles are congruent, I can finish this off by saying angle A is congruent to angle B. And the reason that is because they're corresponding parts of congruent triangles. Therefore, they have to be congruent. Corresponding parts of congruent triangles are congruent.